Hello, myself Rajrupa Metia, Assistant Professor, Department Computer Science and Engineering, Huldia Institute of Technology. Today, I am going to discuss the most interesting area of AI, artificial intelligence, as we all are using in a very huge manner. But we need to know some interesting thing, how the things is going on, how the problems can be solved. There is so much way to solve that kind of problems. But today, I am going to discuss the most interesting topic, that is the constant satisfaction problem. So let's start with the topic. Okay. So first thing is, what is constant satisfaction problem? As by the name we can say that constants means we have some rules, those are not changeable. Then satisfaction, we have to satisfy that rules to solve a particular problem. If we go a very fundamental and a theoretical description, here it is. CSP represent a state with a set of variable or the values pairs and represent the condition for the solution by a set of constants or the variables. As we said that whatever the constants we have to follow to solve a particular solution or the problem. Next, what are the most important area? So solve the thing, basically three basic components of that CSP. Those are the variables, the domain and the constants. What are the variables? The things that need to be determined are the variables. Suppose the values, the categories, the numbers, those are the variables. Next, what is the domain? The range of the potential value that a variable can have is represented by the domains. A simple, if we have a game, suppose Sudoku. So for that we have the rules. What are the rules? Rules are that we are only allowed to use 1 to 9 numbers. Now if we have a 3 cross 3 matrix Sudoku, that means each 3 lines we have different numbers that cannot be repeated once again. That means the first block, if we are using 1, 2, 3, in the second block we are not going to use 1, 2, 3. So for that we have to use 4, 5, 6. But the addition of horizontal, vertical or the diagonal addition will be remain same. So that is the constants. Now here it is. What is the constants? The guidelines that control how the variable relate one another and known as the constant. Simple, as I discussed, the Sudoku problem, the restriction might be that each row, each column and the 3 cross 3 rows that have only used 1 to 9 numbers but without repeating these. So this kind of three things are the basic components of constant satisfaction problems. That means we have to solve the Sudoku by using 1 to 9 numbers either in a row or column or diagonally, and the rules are that the additions of the rows, the columns and diagonal additions will be remain same. Okay. So now how AI can solve this one? How it can be solve this kind of particular problem? The simple thing, CSP algorithm follows basic 3 process. First one, backtracking method. What is the backtracking method? Now it automatically starts to solve a problem. We have a huge big problem. It can categorize or subpart in that problem. Then it starts to solve that subpart. Once it solves, it go for the next. Then next, and then the second part, it always added all previous 3 problems and then it gives the solution. If somehow the result is not as per the expectations or the rules are not maintained, then it again get back to the previous step and go and find for a new solution. That is the backtrack method. As I have said here, the backtracking algorithm is a basic method for solving the CSP. If it completes the encountered, then the algorithm backtrack and tries to solve or find a different value which can be go for towards the solution. Next, forward checking algorithm. What is forward checking algorithm? The simple, if the variable is assigned a value Forward checking checks that the remaining variables to ensure that they are still valid or not. Suppose in the case of Sudoku, if I am going to put the horizontal manner 1, 2, 3, the addition, that is 3 plus 2 plus 1 is equals to 9. I'm sorry, it's 6. Next, we have to add that this addition will be symmetric or not. If it is not, then go back to the another one. If we have a particular solution, then we have to check how many values are still remaining. That can be used because already we have said that we are not going to use the same numbers repeatedly. Next, the constant propagation algorithm. What are the constant propagation algorithm says? Now it says enforce constants during the search process by ensuring that each variable is consistent with the constraints before it proceeding. That means when we need going to proceed the next one, it always checks that if the constraint is propagation or not. Basically, it's a very tough topic. It's going to be getting bored. Let's get some example how CSP works. CSP works in a very nice manner. The examples of the CSP is cryptarithmetic, crossword puzzle, n-queen puzzles, map coloring. Those are the most interesting area. Still it is used. Now, I know it's getting too bored. So, let me make that CSP quite easier with a very interesting example. So, let's start with the cryptarithmetic. That is our first topic. We are going to use example by using cryptarithmetic to solve by the CSP. That means we are going to solve a particular problem by using the constant satisfaction problem. Okay, so what is this? So before going to that, let me tell you one thing. That is the constant satisfaction problems. There are the set of variables as we have discussed. That is the V1, V2, V3 up to Vn number of n. The non-empty domain for every single variable. What are the every single variable? That is D1, D2, Da2 up to Dn. That is what are the domains. Okay. The finite set of constants. What are the constants? As we said that those are the rules. What we need to be followed. Suppose x1 and x2 both have the domain A and B. x1 and x2 we are getting to values, the finite variables, and the domain are A and B. And the rules is that x1 and x2 be either A or B domain or B or A2 domain. But they are never will be the similar. That is my constant. Now depending on that, I have to solve it. Okay, go for the example. Okay, so here it is the examples of cryptarithmetic. Cryptarithmetic is that you can say the mathematical puzzle, or you can say it's a very cryptography type things, very interesting one. Suppose we have some encrypted message. Two math numbers, as you have seen that here I have used two things. That is the send, SEND, and plus MORE. There are 8 letters, alphabets, and the addition of those 4 and 4 alphabets is MONEY, money. That is one 5-digit alphabets. Now, the most interesting thing is that we have to find out the values of each alphabet here, so that when the values of A, S, E, N and D, that mathematical value will be added with the MORE. The addition result will be MONEY values. But in both cases, the thing is that the M value will be similar, as we have seen that the blue line as well as the green line. Okay. Now, that is my conditions is that we are not allowed to use same values for each individual alphabets repeatedly. That means if I fix the value S equals to M, S equals to 1, that one will be not allowed for the another value. That means same value will be not repeated for any same different alphabets. And the addition should be 1 to 9. That means we have to use 0 to 9, and then after we have to add it. Let's start with this. So basically what we know, If we have single digit number, 1 plus 1, what will be the addition? 2. Fine. 1 plus 2, 3. So in this manner we can see that up to 5, 5 plus 5 or 5 plus 4, we have the 9. But if we have two number 5 plus 6, we have a double digit number. That means we are adding two single digit number that will be resultant of a double digit number. But the most interesting thing that if we add 9 plus 9, the maximum value, 9 plus 8, and as far my concentration is that the constant is that we are not going to repeat the same values. That means I have the maximum values 9 and 8, and if I add 9 and 8, I only got 17. So this 17 is a two digit number. That means maximum two one digit number will be added and we get a two digit number. Am I clear? Okay. So right now we are going to solve it. So here we have 4 digit numbers, A, C and D, then the mode, then the result is 5 digit numbers. That means the leftmost bit definitely forward or carry one carry. As the numbers we said that it is a maximum one digit number, so definitely consider the leftmost place always will be 1. Okay, so what is the leftmost place? My result shows that my leftmost place is M. So if I consider M equals to 1, we just make it M equals to 1. That means the addition of S plus M will be the resultant equals to the 0. Then along with that the carry is 1. That means M and O is the addition of S and M, and that is give us a two digit number. Okay, so we consider M equals to 1. Okay, as we have M equals to 1, we put that 1 plus S equals to 0 or O. Now, what is the value of O? We have already used M equals to 1, so 1 cannot be used for the next time. So we consider S plus 1 equals to the value, whatever the result, that will give me the values. So what is the condition? If we put O equals to 0, what will happen by that? So if we put O equals to 0, I like to check it out. If we put O equals to 0 in this line, if we put O equals to 0, what will happen? M equals to 1, S equals to 0. That means whatever the value of S, so we can consider, have two values already, 0 and 1 we already used. So what we have left? 2 to 9. Now we consider S equals to 8 or 9. Why not another number? Because already we know that S plus M, the addition will be containing the value whose rightmost value will be 0 and leftmost value will be 1. So we can say that if my M equals to 1, O equals to 0, my S equals to 9. Okay, so now we find my S equals to 9. Now we are going to put the value of S equals to 9, M equals to 1, here M equals to 1, the O value put it on here, that is a 0, and another one wherever I have the another O, that is just after the E, that is the 0. So I will be going to put the values. Now we have to find out the next values. Now we have only E will be added with 0 and the resultant will be the N, and obviously that will be added one extra carry. Why? Now we have added 9 plus 1 equals to 10. Already those portions are sorted, and we have seen that if we do not have any carry, we are not going to sort it out the additions of N and R. So for that, what we that? In this possible case, we are using N plus R equals to 10 plus C. That is my first equation, and my simple mathematical equation says that 1 plus N plus R equals to 2 plus E. And from these two equations, we can find it out. E equals to N minus 1. From the first equation, we get R equals to 9. But this r equals to 9 is not possible. Why not possible? Because in our previous slides, if we go for that, we have made it that is equals to 9 and we are not allowed to use the same value for the different variables. So we already lost the value 9. So how many the maximum number value still in my pocket? So that is the 8. Now check it out. If we consider r equals to 8, then what is the value? 1 plus n plus r equals to 10 plus n minus 1. Used by a simple mathematics process, we have r equals to 8. That means we got the value of S, M, O and R. Okay. Now, what is the value of N? Now we know that E and N are considered in the same value. That not been possible. So, N should be larger than the E. Now, if we take that N and E both are equals to 7 and 6 and we are going to put that values and we have to say that unique values for the D. Why for the D? Now here we are going to add E, N and here we have the E and we are going to get the result D. So from here what we have? Now unique value for the D we need to find it out. If we consider N equals to 6 and E equals to 5, now we get D equals to 7 and Y equals to E. How in the process? Now simple, putting the value N equals to E to the following here. N equals to, we put 6 and we put E equals to 5. So simple process. Now finally what we get is value equals to 9, M value equals to 1, E equals to 5, O equals to 0, N equals to 5, R equals to 7, D equals to 7 and E equals to 5. The addition of these all mathematical numbers are same as by the alphabets. Suppose D and E equals to Y, 5 and 7. By added we have 2, 1 carry that will be forward for the next. 6 and 8 that is getting the alphabets value of 5, N and R, that is the 14 and along with 1 carry 15, 5. Then again the carry will be sent to the next bit. Where is the value? E equals to 5, O equals to 0 and previous carry both equals to 6. Here we have seen that N equals to 6. Now see, already previously we have used here N equals to 6. We have to use N equals to 6 and by adding this 2 we again get back that N equals to 6. Next 9 and 1 added with the 10. 0 is here, 1 carry bit will be forward for the next bit. So that is the 1. So this is the solution of the crypto-arithmetic by using constant satisfaction problem. Here is the problem. We have to find out the values of that alphabets. The variable is that each alphabet have some numerical values and the constant is that we are not allowed to use the same values for different alphabets. Okay, so now this is the most interesting example of crypto-arithmetic by using constant satisfaction problem. Next, we have a look on some real world problem. Those are very puzzle problem, theoretical problems still we have, but CSP not only for that gaming and all those, that is definitely used for the real world problem. What are those real world problems? First one is the CPU scheduling. That is the most, this is how efficiently and effectively schedule resources like personnel, equipment and facilities. The constants in this domain specify the availability and the capacity of each resources. Here is not only the values, constant satisfaction problem is not always giving the values, the numeric values. As we have said that is a set of variables, set of values. So definitely there are some constant, whatever the availability and the capability of the resources, and those are the constants, because my resource, my capability, my availability, those are very constant mode. And wherever the variables are indicated the time slots. Basically, scheduling is using for the time slots. Next, vehicle routing. For this issue, minimizing the travel time or distance by optimizing the fleet of the vehicles route. So in this domain, what are the constants? Constants are that the vehicle capacity, the delivery location, and the timing window. That means we need to go from one direction to another direction, one spot to another spot, whatever the distance, whatever the time, how many vehicles are allowed for that road, those are the very constant ones. And wherever the variables are that, the routes which we are taking. The variables are which the route we are taking. Suppose we need to go from A point to B point, and there are several ways to covering those from A to B. Now we need to find out which one is the most convenient option for us. So for that we are using constant satisfaction problem. Next one is the assignments. How to optimally assign assignments or job for the humans or the machines or whatever. So in this field, variables are the task. Maximum tasks, as we say, that the variables v1 to v9, that means tasks are always definitely the variables there. We do not know how many numbers of tasks are there that can be performed by the human or the machines. That will be the variables. And what are the constants? Constant is the knowledge, the capacity, the workload of each person or the machines. So these are the real world constant satisfaction problem that can be solved by using this algorithm. Okay, and the last not but the least, that is the constant base image segmentation. What is the image segmentation? This area, the suppose the color, texture, shape, as we are basically we are using machine learning or maximum time recognition system especially. So on that time we are using the image in a very large manner. So for that, the color, the texture, the shape, those are treated as the CSP issue to computer visions, and we need to find out the solution how to solve this kind of issues for this where the variables represent the regions of the constant, specifically how similar or unlike neighboring region are they are one another, to solve it out. So this is the there are so many types of examples are constant satisfaction problem in the real world, but these four are most optimal and the main one. Next, we are going to find out the reason why we are using this algorithm. The algorithm is quite tough enough because we have so many constants, we have to deal with a large number of variables, we have backtrack method, we have to forward checking. So there are so many things. That means suppose we have do some problem, then we have to backtrack again, we go for the another solution. So instead of this kind of issues, why we are using CSP? What is the advantage of the CSP? CSP is natural representations for a wide variety of problem. Too much variety you can use. You have many numbers of constants, you have given too much numbers of rules and regulations, along with that you have a heavy number of variables. Those all can be accessed or can be handled by the CSP. CSP solvers can be faster than the state space search because the CSP solver can quickly eliminate the large switches of the search space. That means if we have a maximum number, if we have a large switches, so what will have? State space problem, we have some particular issues, we have to find out the values, then we have to decide which one is the best and then go for that one. But here is case, if it is not follow or it is not satisfied its rules or constants, immediately it gets back to the previous one and go for the next solution. We are not going to explore the other part unnecessarily. And with CSP, once we find out that a partial assignment is not a solution, we can immediately discard further refinement of the partial assignment. As we said that if that is not to my domain, if it is not satisfied my first criteria, definitely you are not satisfied with the next criteria. So immediately I get back to the previous one and go for the another route to find out or to explore the solution. We can see the assignment is not a solution which variable violate a constant. That means if my variable is not in the rules or the constants, If it is valid a constant, we are not going to find out any solution. Immediately, we're going to stop it. So these are the advantage. That's why basically structural in the way we are using the CSP instead of other searching algorithms. Thank you.